Okay, so this is our last video, and we're going to have 3 examples here that we're going to run through. The first example says find the sum of the first 40 odd numbers. This might be something that you might see on a standardized test. So we're going to just say, all right, first 40 odd numbers. That's 1 plus 3 plus 5 plus 7 plus 9 plus ... We don't know what the last number is, but we know it stops somewhere. We could figure that out using some of our other formulas like a sub n equals a sub 1 plus n minus 1d, but we don't have to. Okay, we know our first term is 1. We know our common difference is 2 because it goes up by 2 each time. We know that n is equal to 40. And luckily we have this equation, s sub n equals n over 2 to a sub 1 plus n minus 1d. Plug it in. S sub 40, 40 over 2, 2 times 1, 40 minus 1 times 2, 22 plus 39 times 2, 22 plus 78, 20 times 80, 1600. And so the sum of the first 40 odd numbers, odd integers, positive numbers, is 1600. Pretty easy to do if you know the formula. Okay, here is another one. An amphitheater has 40 rows of seats, 30 in the first row, 32 in the second, 34 in the third, and so on and so on. Find the total number of seats. So what we're going to do is we're going to say, okay, well, the first row is 30, second row 32, third row 34, 36, all the way until the 40th row, which would be a sub 40. Now this one I'm going to take a slightly different approach because I could easily ask you how many seats are in the 40th row. If that's the case, I'm going to use a sub n equals a sub 1 plus n minus 1 times d. So a sub 40 equals 30 plus 40 minus 1 times 2, because they go up by 2's each time. 30 plus 39 times 2. And that would be, let's see here, 39 times 2, 78, 108. So there's 108 rows or chairs in that last row. So we know it goes here to 108. That's a sub 40. Now I'm just going to use a different formula, the n over 2 first term plus last term. You might want to use this formula if you want to just remember 2 formulas. And so we'd say s sub 40 equals 40 over 2. First term is 30. Last term, 108. 20 times 138. And you get 2,760 seats in this amphitheater. Okay? Pretty cool problem. And then the last one is how many terms of the arithmetic sequences 3, 5, 7 must be added to get 624. So we know our first term is 3, we know our common difference is 2, and we need to find n, but we know s sub n is 624. So I'm just going to use my s sub n equals n over 2 to a sub 1 plus n minus 1d. Again, I said that formula is going to be very important. You can see that it is. This here is going to be 624 n over 2, 2 times 3 plus n minus 1 times 2. We got to solve for n. First thing I'm going to do is multiply both sides by 2. That makes it pretty easy to get rid of that part. Those 2's would cancel. I get 1248 equals n times 6 plus 2n minus 2. Just distributed there. 1248 equals n times 4 plus 2n. distribute the n, and I get 4n plus 2n squared, 1248. We'll set it up as a quadratic, so 2n squared plus 4n minus 1248 equals 0. Factor out the 2. That's 624. Now I need to factor. Okay? Two numbers that multiply together give me this, and add together give me this. It's going to be n plus 26, n minus 24. Because 26 times negative 24 is negative 624. 26 plus negative 24 is 2. So that gives me n plus 26 equals 0, so n equals negative 26. N minus 24 equals 0, so n equals 24. Can I have a negative number of terms? No. And so in this case, it's 24 terms that need to be added up to give us 624. So that's the trickiest these are going to get. Again, the key is remembering the formulas. Remember the formula for finding any term in an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. And then the sum formulas are a s sub n equals n over 2, a sub 1 plus a sub n. That one's easy if you know the last term and the first term, or if you know the common difference, you can do this. S sub n equals n over 2, 2a sub 1 plus n minus 1 times d. Hope you enjoyed them. Good luck on working some of those problems out.